Hello all, welcome to this session. Let's get to the topic. To start with the components of a battery pack. On the left side, you can see a schematic of a battery pack which details the major components inside a battery pack. On the right side, you see a model battery pack. This is from a Nissan vehicle. And this is also seen in the previous session. Yeah, let's go into each components. The major components are modules, you can see it here, the battery modules and the battery management system. And you see switch box, it's nothing but the relays or the control switch which are used for the circuit breaker and the circuit closer. You will understand on which situation we need to open and which situation we need to close the circuit. Yeah, and you find a cooling system. Yeah, certain battery packs might need an air-cooled system that is sufficient, say a lesser voltage like around 48 volt system. It does not need a complicated or a sophisticated cooling system. When the voltages increases, the thermal energy increases, the heat produced by the battery pack will increase. In that cases, we might need a liquid cooled system. You see housing or interfaces block. It is nothing but the upper cover, the bottom cover, and the structures which are needed to hold the battery modules and other components together. So that is put in one block. Yeah, as you see, these are the major components of a battery pack. Okay, so outside you might see it as a complete pack, but it comprises of all these things, starting from battery modules, battery management system, relay or a control switch, bus bar, cooling system, housing and interfaces. And battery modules, you might already know what is a battery module, but I will repeat it again. Group of cells that are connected in series, sometimes in parallel as well, in order to increase the capacity. Based on capacity and the voltage, we align the cells in the number of series cells, and the number of parallel packs are also decided based on the requirement of voltage and the capacity. So such group of cell is called as a module, and group of modules will come together inside a battery pack. Yeah. Okay. Then we move on to the relay, switch or contactors. Any term can be used in battery management system world or a battery pack world. So basically the relay, switch or contactors are used to close the circuit, that is connecting the circuit and opening the circuit. And all these things are based upon the situations in which we need to actuate. Say for example, if you are starting a driving cycle, consider an electric vehicle. When you do a key on, it is expected that the circuit should close. Once the circuit closes, only then there will be flow of electrical energy. So the relays will close. Similarly, at the end of the driving cycle, when you switch off the key, then the circuit has to open. Yeah, then the relay, switch or contactor will be opening. So based on the intended function, the relay and switch controls will be controlled by BMS. Okay, the battery management system. We will see it in detail in the upcoming slides and the sessions. Yeah, and also relays are opened in case of some protection need. So if there is a scenario where there is over voltage detection, then again you will have to do a protection, right? So you will open the circuit and then protect it. Yeah. We'll move to the next component, that is nothing but the bus bar. They are nothing but the high voltage power lines. The power lines which you saw in the previous slide. So they are called as bus bars. That is how the technical term. The thickness of the bus bar and the material used, it depends upon the amount of current that is going to flow and the voltage that the battery pack is decided for. Then we move to the cooling system. As I already given you a brief, cooling system we will use basically to cool. Why do you want to cool a battery pack? And when a battery pack gets heated, it is simple. The battery pack gets heated during charging as well as during discharging. So you know what is a battery pack and what is its function. It is basically the electrical energy will be stored inside a battery pack in the form of a chemical energy during charging, and the chemical energy will be converted back into an electrical energy during discharging. So this exchange of energy, or I would say the transfer of energy from electrical to chemical and the chemical to electrical, will produce heat. This generation of heat sometimes can go in excess. In order to have an optimum performance of a battery pack, we need to maintain the temperature of the battery pack, okay, into an operating range in which the efficiency of the battery pack will be at its maximum. So in order to achieve that, we want a cooling system. The cooling system either can be air cooled or liquid cooled. It all based upon the application of the battery pack and the capacity of the battery pack. Say in case of 48 volt system, an air cooled battery pack would be sufficient. Wherein in case of a 380 volt system or 600 volt system or even a 900 volt system, we may need a cooling system which is more efficient than an air cooled. So we prefer the liquid cooled system. Yeah, okay. So next comes the housing or the interface. It is basically nothing but the cabinet which covers the top cover of a battery pack, the bottom cover of a battery pack, and the frames that are inside the battery pack in order to hold each module in its place. This is called or grouped and called as a housing or an interface. So before we try to understand about the functions of a battery management system, I just wanted to explain you the components of a battery pack. So I hope you understood the components of the battery pack now.